Good morning and welcome to lesson 11 for our unit. It's actually the last lesson in the unit. Congrats on getting here. This is the Conservation of Momentum 2, jokingly called Math Boogaloo. So now we're going to be learning to understand and apply the law of conservation of momentum to collisions, including using m1v1 plus m2v2 equals m1v1 plus m2v2, which is a lot of letters, looks complicated, but it's very straightforward once you understand it. So we're going to break down what this formula actually means and then look at some examples. So m1v1 plus m2v2 equals m1v1 plus m2v2. So first thing we want to notice here is that both sides are exactly the same. The numbers in here are subscripts. Remember that the subscripts are put in here just to label, because there's more than one mass and more than one velocity. And so to keep them straight, which is which, we're labeling them. So for like object 1, its mass is mass 1, its velocity is velocity 1. Okay, so right here, that white ball is object 1. And like I said, mass 1 is its mass 2 is the mass of the red ball, or orange ball in this case. Very straightforward, very simple. Okay, now let's assign a velocity to this white ball. Let's say that white ball is going 5 meters per second, just to make things a little bit easier for us. The red ball at the start is obviously not going anywhere, 0. So that's our formula, right? m1v1 plus m2v2 is equal on both sides. So 0.1 kilogram times 5 meters per second, that's the first part, plus 0.1 kilogram times 0 meters per second, that's the second part, is equal to m1v1 plus m2v2. Okay, so on the other side, we know that this white ball is still 0.1 kilograms, and we know that the red ball is still 0.1 kilograms. Mass didn't change. But we can see after the collision that the first ball, the white one, isn't moving. So now it has 0 meters per second. And what we don't know is the velocity of the second ball. Now, this math is really, really obvious, I think, to us, but it supports our last lesson about how it's the same on both sides with a math model, right? In this example, that 5 meters per second has transferred to the second ball, which is why it moves with the same velocity as the first ball. They have the same mass and all of the momentum transferred. Now let's look at this inelastic example down here, okay? So let's say this orange car is 1,200 kilograms. We're going to use real big numbers now, big, because we're talking about cars. The blue car is 800 kilograms. The orange car was originally going 15 meters per second. And let's say the blue car is originally going 10 meters per second. So we set this up as 1,200 times 15 plus 800 times negative 10. So let's do the math on that. We get 18,000 for our first number. That's the momentum of the orange car. Negative 8,000 is the momentum of the second car. When we combine them, 10,000 has to be the momentum of our cars afterwards when they're moving together. Okay, so 10,000 equals 2,000 kilogram times V1 plus 0 kilogram times 0 meters per second. This is the phantom car. Boo, because there isn't a second object to worry about anymore. So we'll say that there's nothing else to worry about here. We're just looking at the combined mass of those two cars, okay? So 10,000 divided by 2,000 means the velocity of these cars is 5 meters per second. Amusingly, the same as our balls were in the example on the other side. And that's it. That's the whole thing. This is the math. Come back to this if you need to reference it multiple times when you're doing the math practice, okay? But this is basically the end of our physics journey in this unit. And when we talk after this, we're going to be working on our final project. So good luck.